Welcome back to Machine Learning Guide. This episode was AI generated. I do this for fast-moving topics like OpenClaw, Claude Code, vibe coding, where the landscape shifts faster than I can personally keep up. For foundational episodes like backpropagation, logistic regression, those are still me. But for bleeding edge stuff, I'd rather you have a solid episode now than a perfect one never. And hey, you can generate audio content like this yourself and even use my voice at ocdevel.com/moremlg. Let's dive in.
You have used Claude Code. You have watched it read your code base, plan an approach, run tests, see them fail, adjust, and try again, all without you typing another word. You have probably thought at some point that this feels like more than a chatbot. You're right, what you experienced was an agent. This guide will help you understand exactly what that word means, why it is different from chat, and critically help you navigate the sprawling landscape of agent tools so you know when to reach for which one. Let's start with Part 1. What is an agent actually? We should start with what it isn't. You already know what a chatbot is. You type a message, it responds. You type another, it responds again. Even when a chatbot can use tools like searching the web or running code, the interaction pattern is fundamentally turn-based and human-driven. You ask, it answers. You ask again, it answers again. The human is the loop. An agent is different. An agent receives a goal, not a question. Then it does the rest. Now for the formal definitions. The two most useful definitions come from the major labs themselves. Anthropic's definition from December 2024 draws the clearest line. They distinguish workflows, which are systems where LLMs and tools are orchestrated through predefined code paths, from agents, which are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. The key phrase here is that the LLM decides its own next step. OpenAI's definition from March 2025 is blunter. They say that if you're building a chatbot-like experience where the AI system is answering questions, you cannot really call it an agent. If that system is connected to other systems and taking action based on the user's input, that qualifies. Both agree on the essential ingredient, which is autonomy and execution. A chatbot responds to prompts, and agent pursues goals. Think about it through the lens of Claude Code. Since you know it well, when you tell Claude Code to refactor this module to use dependency injection and make sure all tests pass, you're not giving it a sequence of instructions. You're giving it an objective. Claude Code then reads the relevant files, formulates a plan, makes edits, runs the tests, sees failures, reads the error output, adjusts its approach, tries again, and repeats until done, or gives up and asks. That cycle of observe, think, act, observe again, is the beating heart of what makes something an agent. There is no human in the loop between steps 1 and 9. The LLM is driving. The React loop is where this all started. The foundational paradigm behind virtually every modern agent is React, standing for Reasoning Plus Acting, from a 2022 paper by Yao et al. Before React, the ML community treated reasoning like chain of thought prompting and acting, meaning tool use, as separate capabilities. React unified them into a single interleaved cycle. First, thought. The LLM reasons out loud, saying something like, I need to find the database configuration, so let me check config.py first. Second, action. It calls a tool. Third, observation. The tool returns a result, for example, the contents of config.py. Then back to thought. It says, okay, I see the DB connection string is hard-coded, so I need to extract it into an environment variable and let me also check if there is a .in file, and so on, in a loop until the task is complete. This is simple but profound. The paper's key insight was that the reasoning traces help the model induce, track, and update action plans, as well as handle exceptions, while the actions let it gather information it doesn't already have. The two capabilities are stronger together than either is alone. On the ALF World benchmark, React outperformed reinforcement learning approaches by 34% absolute success rate with only 1 to 2 examples. Every single agent you will encounter, including Claude Code, OpenClaw, ChatGPT Agent Mode, LangGraph agents, and N8 and AI agents, is running some variant of this thought to action to observation loop. It is the atomic unit of agentic behavior. Moving beyond React, we have planning, memory, and self-correction. The basic React loop handles one step at a time. Real-world agents need more sophisticated reasoning. First, planning and decomposition for complex tasks. Agents break the goal into subtasks before diving in. An orchestrator agent might decompose a goal like create a competitive analysis report into 4 steps, identify competitors, research each one, compile findings, and write the report. Some agents use tree of thought reasoning, which generates multiple candidate approaches at each decision point and evaluates which path is most promising. This achieves 74% accuracy on problems where simple chain of thought gets only 4%. Memory comes in 2 flavors. Short-term memory is just the context window, meaning everything the agent has seen in this session. You know this well from Claude Code's context limits. Long-term memory persists across sessions. Claude Code's files are a great example, as are OpenClaw's locally stored interaction histories. The gap between remembering what happened 5 minutes ago and remembering what happened last week is one of the biggest practical constraints on current agents. Self-correction is what separates good agents from bad ones. When Claude Code runs a test and it fails, it reads the error, reasons about what went wrong, and tries a different approach. This reflexive capability, the ability to learn from failures within a session, is essential. Andrew Ng popularized this insight. He noted that GPT 3.5 wrapped in an agent loop with self-correction scored 95.1% on HumanEval compared to GPT 4.0 shot at 67.0%. A weaker model with agentic scaffolding dramatically outperformed a stronger model without it. The architecture matters as much as the model. The spectrum is not a binary. Here's something crucial that trips people up. Agent is not a binary yes or no. It is a spectrum. Anthropic explicitly frames everything as agentic systems and places them on a continuum. First, chat, the human asks, and the LLM responds. No tools, no autonomy. Second, chat plus tools. The human asks, and the LLM responds using tools like web search or code execution, but the human is still driving each turn. Third, workflows. These are LLMs orchestrated through predefined code paths. A developer has hard-coded the sequence to first do X, then do Y, then do Z. The LLM adds intelligence at each step but doesn't choose the path. And fourth, agents, LLMs dynamically choose their own path. The system decides what to do next based on what it observes. This spectrum is the single most important concept in this entire guide. It is the key to understanding why N8N in Claude Code and OpenClaw feel so different from each other, even though people call all of them agents. Now, for Part 2, the 5 buckets of agentic tools. Now that you understand the spectrum from workflows to fully autonomous agents, let's map the actual tools onto it. I'm going to organize the landscape into 5 distinct buckets, ordered roughly from most controlled to most autonomous. For each one, I will explain what it does, how it relates to the agent spectrum, and when you would choose it. Bucket 1 is agent SDKs and frameworks, where you build the agent. These are developer libraries and frameworks for building custom agent systems from scratch. You write code that defines agents, their tools, their reasoning patterns, and how they coordinate. On the spectrum, these are toolkits, not finished products. They can build anything from simple workflows to fully autonomous agents. So you decide. The major players include the Claude Agent SDK from Anthropic, released September 2025. It wraps the same infrastructure powering Claude Code into a general-purpose Python and TypeScript framework. Agents get built-in tools for file operations, bash commands, web search, and code execution. It integrates deeply with MCP, which we will discuss shortly. The design philosophy is to give your agents a computer. The constraint is that it is for Claude models only. Next, OpenAI Agents SDK from March 2025 is deliberately minimalist. It has 4 primitives, agents, which are LLMs with instructions, handoffs for transferring control between agents, guardrails for validation, and sessions for conversation history. It is open source and model agnostic, working with over 100 LLMs, not just OpenAI's. It is good for lightweight systems where you don't need complex orchestration. Then there's LangGraph by LangChain, version 1.0 released October 2025. It is the most mature option for complex agent orchestration. It models agent logic as a graph, where nodes are processing steps and edges are transitions. This gives you explicit control over branching, looping, and parallel execution. It has durable state, meaning execution persists through restarts, built-in human in-the-loop APIs, and production infrastructure via Langsmith. About 400 companies deployed it during beta, including Uber, LinkedIn, and Klarna. The trade-off is a significantly steeper learning curve. Crew AI has $18 million in funding and over 44,000 GitHub stars. It takes a different metaphor. Instead of graphs, you define agents with roles, goals, and backstories, and they collaborate through delegation, like assembling a team. A researcher agent gathers information and passes it to a writer agent. It is the most intuitive framework for multi-agent systems and claims 5.76 times faster execution than LangGraph on certain benchmarks. 60% of the Fortune 500 are customers. Google ADK, or Agent Development Kit, from April 2025 is the newest major entrant. It is open source, supporting Python, TypeScript, Go, and Java. It is optimized for Gemini, but model agnostic. Microsoft is transitioning from AutoGen, which is now in maintenance mode, to the Microsoft Agent Framework, merging AutoGen's multi-agent orchestration with semantic kernel's enterprise features. They are targeting general availability in Q1 2026 with deep Azure integration and enterprise compliance. When should you choose this bucket? When you're building a product with agentic capabilities, you need precise control over agent behavior, tool selection, error handling, and cost. You have engineering resources and want to own the architecture. Start simple. Use OpenAI Agents SDK for lightweight systems, LangGraph for complex stateful workflows, and Crew AI for intuitive multi-agent collaboration. A critical piece of infrastructure here is MCP. The Model Context Protocol, introduced by Anthropic in November 2024, has become the universal standard for connecting agents to tools in under 12 months. Think of it as USB-C for AI tools. It is a standardized interface so any agent can talk to any tool. OpenAI adopted it in March 2025, and Google in April. By November 2025, it was donated to the Linux Foundation. The ecosystem now has over 10,000 MCP servers and 97 million monthly SDK downloads. Every framework listed above supports it. You know, MCP from Claude Code, it is the same thing that lets Claude Code connect to your GitHub, your database, and your project management tools. Bucket 2 is workflow automation platforms, where you design the pipeline. These are visual, low-code, or no-code platforms where you design automation pipelines by connecting triggers, actions, and AI decision points in a flowchart-like interface. On the spectrum, they sit firmly on the workflow side. This is closer to Anthropic's definition of predefined code paths with LLM intelligence at each step. The human designs the flow, and the AI adds smarts within that flow. The major players include N8N, which is open source and self-hostable. It has become the dominant platform here. It offers dedicated AI agent nodes with LangChain under the hood, MCP server support, sub-agent architecture, and human-in-the-loop approval. It has over 800 integrations and is free to self-host. The big limitation is that agents are stateless. They lose all context when a workflow ends, with no persistent memory between runs without external databases. Zapier rebranded to Zapier Agents in January 2025, calling them AI teammates with access to over 8,000 app integrations. You train agents via natural language prompts and insert them into Zap workflows. Make, formerly Integromat, launched AI agents in beta in April 2025 and unveiled a redesigned visual agent builder in October 2025, where any Make module becomes a callable tool for an AI agent. How is this different from real agents? This is a critical distinction. When you build a workflow in N8N, you're drawing a flowchart. When an email arrives, extract the data, check the CRM. If customer exists, update the record. If not, create a new one. The AI makes decisions within each node, for example, extracting data from unstructured email text, but the sequence of steps is predetermined by you. The AI doesn't decide to check Slack before updating the CRM, the path is fixed. Compare that to Claude Code, where you say fix the failing tests and the agent decides entirely on its own what files to read, what changes to make, what tools to use, and in what order. That is the workflows versus agents distinction in action. So are workflow tools agentic? Partially. They sit in a genuine middle ground N8. N's AI agent node, for instance, runs a real React loop. The LLM can choose which tools to call within that node, but the node itself exists within a predetermined pipeline. It is agentic behavior within a structured container. Choose this bucket when you need to connect existing business apps like CRM, email, calendar, and databases with some AI decision-making, also if your team is non-technical or semi-technical, and if tasks follow known patterns with clear triggers and outputs, like when X happens, do Y reliability matters more than flexibility here. The integration ecosystem, especially Zapier's 8,000 plus apps, is the killer feature. Do not choose this if you need the AI to figure out what steps to take. Not just execute pre-planned ones, or if the task is open-ended, unpredictable, or needs deep reasoning chains and persistent memory across sessions. Bucket 3 is coding agents, where AI writes and runs code. These are AI agents specialized for software development. They understand code bases, write code, run tests, debug, and iterate. On the spectrum, these are true agents in the fullest sense. They autonomously plan, act, observe, and self-correct, but they operate in a constrained, verifiable domain, where code either compiles or it doesn't, and tests either pass or fail. This is why they work so much better than general-purpose agents. You already know Claude code, so I won't belabor it, but it is worth noting why coding agents are 2 to 3 years ahead of every other agent category. It is because of tight feedback loops. When Claude Code edits a file and runs the tests, it gets an unambiguous signal. Pass or fail, with specific error messages. This is the perfect environment for the React loop. Compare that to a browser agent trying to book a hotel. How does it know if it picked the right hotel? The signal is ambiguous. That is why coding agents work and general-purpose agents are still rough. The competitive landscape beyond Claude Code includes Cursor with a $29.3 billion valuation and $1 billion in ARR. It focuses on IDE-integrated, multi-model workflows. Its 2.0 release can run up to 8 parallel agents. GitHub Copilot has the largest installed base with over 15 million users and added a coding agent that you assign GitHub issues to, and it autonomously creates PRs. Windsurf, acquired by Cognition in 2025, differentiates with its Cascade context engine. On the low-code end, Lovable with 100 million ARR in 8 months, and Bolt.new let non-programmers generate full-stack apps from descriptions. Choose this bucket if you are writing software. That is it. These tools are purpose-built and dramatically more reliable than general-purpose agents because of the verifiable feedback loop. Bucket 4 is desktop and browser agents, where AI operates your computer. This is where things get exciting and messy. This bucket contains agents that interact with your computer the way a human does, clicking buttons, filling forms, reading screens, navigating websites, and managing files. It is the most rapidly evolving category and the one most likely to affect non-developers. There are several distinct subcategories here, and the differences matter. First, Claude Cowork, the desktop agent. Released January 12, 2026 for Mac with Windows added February 10, Claude Cowork extends Claude Code's agentic architecture to general knowledge work. It is built into the Claude desktop app. The concept is simple. Point it at a local folder, describe an outcome, step away, and come back to finished work. What makes co-work different from regular Claude chat is fundamental. In chat, you interact one message at a time. In co-work, Claude plans and executes autonomously. It creates formatted documents like Excel with real formulas, PowerPoint, and PDF reports. It organizes files, coordinates multiple sub-agents working in parallel, and runs for extended periods on complex tasks. It operates inside an isolated VM for safety, powered by Claude Opus 4.6 with a 1 million token context window. Think of it as Claude Code for everything that isn't code. Where Claude Code excels at refactoring a module, Co-work excels at synthesizing a research report from a folder full of PDFs, cleaning a messy CSV, or building a presentation from raw data. 11 official plugins cover sales, legal, finance, and marketing. MCP connectors link it to Google Drive, Gmail, GitHub, Slack, Asana, and more. The key limitation is no memory across sessions. Every co-work task starts fresh. Next is Claude in Chrome, the browser agent. Launched as a research preview in August 2025 and expanded to beta for all paid subscribers in late 2025. This is a Chrome extension that lets Claude see what is in your browser tabs and take actions. Navigate websites, click buttons, fill forms, extract data, and run multi-step workflows across multiple sites. The crucial thing is that it pairs with co-work. Chrome navigates and gathers information from the web. Co-work produces finished documents from that information. Together, they form a pipeline. Research online, then produce polished output locally without you copy-pasting between them. Browser agents are inherently riskier than other agent types because every web page is a potential vector for prompt injection, which are hidden instructions that could hijack the agent.
You spend hours learning to optimize model performance, but here's something uncomfortable. Prolonged sitting reduces cerebral blood flow, impairs executive function, and degrades working memory, the exact faculties you need to learn this material. Chronic sitting is associated with reduced hippocampal volume, the region responsible for learning and memory. A walking desk fixes this. A slow treadmill under a standing desk, 2 miles an hour, no sweat, no time carved out of your day. A Stanford study found walking increases creative problem solving by 60%. Separate research shows it raises BDNF. That's the protein directly responsible for neuroplasticity and long-term memory formation. It increases cerebral blood flow by around 15%. And it sustainably improves focus, mood, and energy through endorphin release. I record this podcast on one. I study on one. I code on one. It's the single most important change I've ever made to my focus, energy, mood, and health. I've tested dozens of walking pads and standing desk setups. My top picks and setup guides are at ocdevel.com/move. That's ocdevel.com/MOVE.
Anthropic has invested heavily in prompt injection defenses, getting attack success rates down to around 1% on their latest models, but the problem is not fully solved. Then we have ChatGPT Atlas, the AI browser. OpenAI took a different approach. Instead of a Chrome extension, they built an entire browser. ChatGPT Atlas, launched October 2025 on macOS, is a Chromium-based browser with ChatGPT built into every tab. It has a sidebar for chat and an agent mode where ChatGPT can control the browser directly, opening tabs, reading pages, filling forms, and completing transactions. Where Claude's approach is an extension sitting alongside your browser, OpenAI's approach is that the browser eyes the agent. Agent mode can handle end-to-end tasks like researching a meal plan, building a grocery list, and adding items to a delivery cart. Plus and Pro subscribers can access it, and it works in Atlas or in ChatGPT's web interface as a standalone feature called ChatGPT Agent Mode, formerly Operator. Other browser agents worth knowing include Perplexity. Comet from July 2025, an AI-native browser focused on search and research. Felu, a spatial agentic browser for deep research across logged-in accounts. Browser use, which is open source with over 21,000 GitHub stars, is a Python library for building your own browser agents with Playwright. And Dia by the browser company makers of Arc, which was acquired by Atlassian for $610 million. Choose browser and desktop agents when you have knowledge work tasks that involve gathering information from the web, producing documents, organizing files, or operating across multiple applications. Also, if you want to delegate tedious multi-step processes like expense reports, competitive research, and data entry to AI. But you must be comfortable with the current reliability limitations, as these are powerful but imperfect. Bucket 5 is free-reign autonomous agents, where AI does everything. This is the Wild West. These are agents that run locally on your machine or a server, connect to your real accounts and services, and autonomously execute tasks with broad permissions across your entire digital life. The big leap from Bucket 4 is that these agents aren't confined to a browser window or a single application. They have access to your email, calendar, messaging apps, terminal file system, and APIs all at once. OpenClaw, the viral autonomous agent, is the phenomenon that defines this category. Originally called ClaudeBot, then Moltbot, then OpenClaw, which is all lobster-themed. It was created by Peter Steinberger and open-sourced in November 2025. It exploded in late January 2026, gaining 60,000 GitHub stars in 72 hours, eventually passing 175,000 stars and an estimated 300,000 to 400,000 users. Here's what makes OpenClaw fundamentally different from everything else in this guide. First, it is a local agent that connects to your tools. OpenClaw runs on your own hardware and connects to your messaging apps like WhatsApp, Telegram, Discord, Signal, iMessage, and Slack. You interact with it by sending messages in your normal chat apps. Under the hood, it routes your messages to an LLM, being model agnostic, and the LLM can use a broad set of tools including email, calendar, terminal commands, file system, web browsing, shell scripts, and over 100 community-built skills. It can do things while you sleep. OpenClaw agents have processed thousands of emails overnight, built websites, controlled smart home devices based on biometric data, and even hired humans via TaskRabbit to complete physical tasks. Users have configured teams of multiple agents that work around the clock. It also writes its own skills. If OpenClaw doesn't have a capability you need, you can describe what you want, and it will write the code to create a new skill for itself. This self-expansion capability is what prompted people to call it Jarvis. The security situation is terrifying. This is not hyperbole. OpenClaw requires broad system access to function, and misconfigured instances are a serious risk. Kaspersky found 512 vulnerabilities, including 8 critical ones. Cisco discovered a third-party skill that performed data exfiltration. CrowdStrike released a dedicated scanner to detect OpenClaw installations in corporate environments. One of OpenClaw's own maintainers warned that if you cannot understand how to run a command line, this is far too dangerous of a project for you to use safely. On February 14, 2026, Steinberger announced he was joining OpenAI, and OpenClaw would be moved to an open-source foundation. How does OpenClaw differ from Claude Cowork? Cowork is a first-party product from Anthropic with built-in safety measures. It runs in an isolated VM, requires explicit permission for file deletions, and blocks high-risk categories. OpenClaw is a community-driven open-source project that gives the agent access to everything on your system. Cowork is a walled garden. OpenClaw is the open prairie. Cowork trades autonomy for safety. OpenClaw trades safety for power. How does it differ from Claude Code? Claude Code is a specialist coding agent operating in your terminal on your code base. OpenClaw is a general-purpose life agent operating across your entire digital existence. Claude Code benefits from tight feedback loops. OpenClaw operates in the messy, ambiguous real world. How does it differ from workflows like N8N or Zapier? This is perhaps the most important distinction. In N8N, you draw the flowchart. In OpenClaw, there is no flowchart. You send a message like clear my inbox of spam and summarize urgent messages, and the agent decides entirely on its own how to accomplish that. It might check your email, categorize messages, unsubscribe from newsletters, draft replies, and create a summary document, choosing each step dynamically based on what it observes. That is the difference between a workflow and a true autonomous agent. Choose this bucket if you're technically sophisticated, comfortable with security risks, and want maximum autonomy. You want an AI that can operate across your entire digital life, not just one app or domain. You're willing to invest time in configuration and security hardening. You understand that this is early, raw, and sometimes dangerous, but the potential is enormous. Do not choose this if you work with sensitive data, cannot evaluate the security implications, need enterprise-grade reliability, or want something that just works out of the box. Now for part 3, how to choose the decision framework. The 5 buckets are not competing alternatives. They are different tools for different problems. Here's how to think about which one to reach for. If you need to automate a known, repeatable process across business apps, use workflow tools like N8N, Zapier, or Make. You know the steps. You just want them to happen automatically with AI handling the messy parts. This is the lowest risk, fastest to deploy option. If you need to build a custom AI product or integrate agentic behavior into my software, use agent SDKs like Claude Agent SDK, OpenAI Agents SDK, LangGraph, or Crew AI. You're an engineer building something novel. You need control over the architecture. Start with the simplest framework that works and add complexity only when needed. If you need help writing, debugging, or managing code, use coding agents like Claude Code, Cursor, or GitHub Copilot. This is the most mature, most reliable agent category. If your task involves code, use a coding agent. If you need AI to research, produce documents, organize files, or handle knowledge work, use desktop and browser agents like Claude Cowork, Claude in Chrome, or ChatGPT Atlas Agent Mode. These are rapidly improving and already useful for many knowledge work tasks. Cowork is the strongest for document production, while browser agents are better for web research. If you want an AI assistant that manages my entire digital life, use autonomous agents like OpenClaw. This is the most powerful and most dangerous option. You get maximum autonomy but need strong technical skills. Treat this as a power user tool with genuine risk. The hybrid approach is often best. Many real-world setups combine buckets. For example, using Claude Code for development work, Cowork for document production, the Chrome extension for web research, and N8N for the predictable integrations that connect everything together. These tools are not mutually exclusive. Finally, part 4, where this is all heading. In the near term, meaning 2026, we will see standardization and specialization. MCP and its siblings become the HTTP of agents. MCP is already the universal tool connector. Google's A2A, or agent-to-agent protocol, is emerging for inter-agent communication. Together, they will let any agent talk to any tool and any other agent, just like HTTP lets any browser access any server. The W3C is working toward official web standards. This is the single most consequential infrastructure development. Also, vertical agents will win over horizontal ones. Agents specialized for specific domains like coding, legal, sales, and finance will hit production quality first. Gartner predicts 40% of enterprise apps will embed task-specific AI agents by the end of 2026, up from less than 5% in 2025. The OpenClaw moment mainstreams the concept. OpenClaw, going viral in January 2026, showed hundreds of thousands of people what a truly autonomous agent feels like. Even if most users hit issues, the concept is now planted. Steinberger joining OpenAI signals that the major labs see personal autonomous agents as the next major product category. In the long term, 2027 to 2028, agents reshape work itself. Software development transforms first and most dramatically. AI-generated or assisted code is expected to reach 55% in 2026 and 65% in 2027. The developer's role is already shifting from writing code to specifying objectives and evaluating outputs. You have felt this shift yourself using Claude Code. This continues and accelerates, knowledge work follows. Co-work ChatGPT agent mode, and their successors will do for reports analysis and documents what Claude Code did for code. The pattern is the same. Describe an outcome, let the agent execute, review, and iterate. Gartner projects 38% of organizations will have AI agents as formal team members by 2028. Multi-agent coordination becomes the default architecture. Instead of one big agent, systems will coordinate multiple specialized agents, a researcher, a writer, a fact-checker, a designer. Google DeepMind's research shows multi-agent systems can perform 80% better than single agents on parallelizable tasks. And here's the boldest prediction. By 2028, the median knowledge worker will spend more time directing agents than performing tasks directly. The tasks AI agents can autonomously complete with 50% success rate have been doubling approximately every 7 months. Even if this pace moderates, the compounding effect over 2 to 3 years is staggering. The question isn't whether agents will transform knowledge work, it is whether the transformation happens in 2027 or 2029. The winners won't be the people with the most agents. They will be the people who understand the spectrum from workflows to full autonomy and match the right level of agent sophistication to each problem. That is what this guide was for. Now go build something.
Do you ever wonder how I keep up with the AI landscape? I describe my process at ocdevel.com/more-MLG. I use AI deep research to generate episode content, and then I convert that to podcast episodes using AI text-to-speech technology. You can use this workflow for yourself to create additional podcast episodes to listen to, and you can even use my AI voice.
Here's my AI voice in action. Doesn't sound half bad, right? AI through and through, so you can keep on listening to MLG in spirit, but on any topic you're interested in. Go to ocdevel.com/MORE-MLG to get more podcast episodes.
You've been listening to Machine Learning Guide, and I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. It's a start-to-finish audio overview of machine learning principles. Then for topics needing more depth or which are best learned visually, I provide a syllabus of resources at ocdevel.com/MLG. That's ocdevel.com. You'll notice that episode titles start with either MLG or MLA. G for guide teaches theory and fundamentals, where A for applied teaches industry and practical tools. You can listen to either or both depending on your goals. If you want to support the show, like and subscribe in your podcatcher, whether iTunes, Spotify, or YouTube.